Hello, my name is Paul Geyer and I am here today to demonstrate for you one of the new Eat and Learn technical guidance programs for professional engineers, architects, and construction managers. The sample we will be looking at today is ethical issues from the Kansas City Hyatt Hotel collapse. By way of introduction, this is a little bit about me. For 35 years, I was what I call a straight-ahead designer, cranking out drawings and specifications for buildings and related infrastructure. I got registered in a few different things along the way, but I'm basically a mechanical engineer. That was my degree in my first registration. Don't hold that against me. This is not a story about structural engineering. It's a story about people and how they behave. This is the incident we are talking about. In July of 1981, two interior walkways in the lobby atrium of the newly constructed Hyatt Regency Hotel in Kansas City, Missouri, collapsed. There was a resulting loss of 114 lives and injuries to 200 others. It was the most tragic structural engineering failure in U.S. history. This is the story of that tragic event. I will be talking about the history of the project, the specific structural engineering failure, and the post-mortem, that is the finger pointing. And this, at the post-mortem, in my view, is where the ethical issues arose. This is where the incident occurred, Kansas City, Missouri, not Kansas. This is the building where the collapse occurred. It consists of three modules: a high-rise tower where the sleeping rooms were located, a conference center where the meeting rooms were located, and an atrium-style lobby between the two. Here is a conceptual floor plan. This is a picture of the lobby of the Kansas City Hyatt Hotel today. Note the high open space ceiling. This is typical of many hotels built in the 70s and 80s in the United States and elsewhere. It's likely you have seen some of them over the years because many are still around today. And this atrium design is a key factor in this tragedy. Here is another view. The ceiling in the lobby is at the same elevation as the ceiling of the fourth floor in the sleeping room tower. The atrium configuration presented circulation problems for guests in the hotel. Left unaddressed, this configuration meant a guest staying, say, on the 10th floor of the sleeping room tower and having a meeting on, say, the 3rd floor of the conference center would have to take an elevator in the sleeping room tower down to the 1st floor, walk across the lobby, and take a second elevator up to the 3rd floor of the conference center, and the reverse to return to his or her room. The architectural solution developed to address this awkward circulation pattern was to provide three skyway walkway bridges from the sleeping room tower through the atrium lobby airspace to the conference center module. These walkways were at the second, third, and fourth floor levels. The walkways were suspended on rods from the ceiling structure of the atrium lobby module, which was 4 stories above the lobby floor. Walkways at the second and fourth floor were vertically aligned, and the third floor walkway was offset. This is a plan view of the typical framing scheme for the deck structure of the 3 walkways. This incident consisted of the catastrophic collapse of the 2 walkways at the second and fourth floor levels. This is a picture taken immediately after the collapse. Now let's look at the history of this project, how it was conceived and developed. Pay particular attention to the number of players or actors in this story, because this is only peripherally an engineering story. It's really a story about how people behave. The story begins in 1976 when civic and business interests in Kansas City wanted a major hotel in downtown Kansas City. An entity called the Crown Center Corporation was created, apparently with support from the Hallmark Card Company, which was headquartered in Kansas City, to develop a hotel. Crown Center Corporation was the owner of the project. Crown hired an architect called PBNDML to design the hotel. PBNDML was the master designer, apparently to oversee all aspects of design. PBNDML hired a structural engineering firm, Gillum Colaco, as consulting structural engineer. Gillum Colaco, GCI, subcontracted the structural engineering work to an affiliated firm, Jack D. Gillum and Associates, who we will call Gillum. Gillum prepared approximately 60 drawings for the structural design. Make note of that number, 60 drawings. A company called Concordia Project Management Limited was hired as construction manager. There were, of course, also all of the myriad of other firms involved in the design: civil engineers, mechanical engineers, electrical engineers, geotechnical engineers, landscape architects, surveyors, and so on. Are you beginning to see quite a few actors wandering on stage as this play develops? Design was begun in 1976 and completed in 1978. A company called Eldridge Construction was awarded the construction contract based on lowest cost competitive bidding, traditional design bid build. As has been the industry practice for decades, if not centuries, it is highly likely that Eldridge determined its winning bid by soliciting competitive bids from subcontractors, plumbing subcontractors, electrical subcontractors, steel erection contractors, subcontractors, selecting the lowest subcontract bids, adding his overhead and profit, and that was Eldridge's bid, a very common way of doing business. One of these subcontractors was a company called Havens Steel, which obtained the contract for the structural steel fabrication and erection work, presumably based on the lowest bid for the subcontract. Havens advertised itself as to the public as being capable of designing as well as fabricating and erecting steel structures. As the business of steel structure design and construction has evolved over many decades, the design work has commonly been divided between the nominal, quote, structural engineer for the project, end quote, and the, quote, steel erection subcontractor. A simplistic but reasonable way to visualize this practice is to say that the nominal structural engineer sizes the beams and columns, say, but the erection contractor designs the connections and other details. Havens subcontracted its portion of the steel design work to a company called WRW, which had a registered professional engineer as a principal. WRW prepared over 40 drawings for the structural design. Note and compare this to the approximately 60 drawings prepared by the nominal structural engineer Gillum. Not that much difference between the two. Crown hired an inspection firm called H&R Inspection General Testing to assure the quality of the construction work and conformance with the drawings and specifications. General Testing had a registered professional engineer on its staff. Are you noticing the stage getting increasingly crowded as more actors wander on for this play? Some additional data points to be considered. 3 times Gillum requested funding to have a full-time inspector on the job, but all requests were denied. Who denied them? The construction manager, the owner? Was the Hyatt Hotel Corporation, the operator of the hotel, involved? The structural specifications for the project were not prepared by the structural engineer Gillum, but by the architect, PBNDML, the master designer. Was this for cost-saving reasons? During construction in October of 1979, a portion of the atrium ceiling structure collapsed. This occurred on a weekend. No workers were present and there were no injuries or fatalities, fortunately. But this certainly indicated something was not right with the steel structure for the project. Crown, the owner, hired an independent structural engineering firm, Seiden Page, to investigate the cause of the collapse, but not to review the complete structural design. Should this have been done? Was this done for cost-saving purposes? Are we continuing to see more and more actors in this play? Are we seeing economic pressures playing a part in this story? Construction was completed and the hotel was opened for business in July of 1980. In July of 1981, about 1,500 people were in the atrium lobby attending a dance contest sponsored by a local radio station. Many of these people were on the 3 aerial walkways. Without warning, the walkways that were aligned at the 2nd and 4th floor levels collapsed. There were 114 fatalities and 200 injuries. The 4th floor walkway collapsed onto the 2nd floor walkway directly below, and both collapsed to the ground floor of the lobby below. Here is the result. Here we see the second and fourth floor walkways that have collapsed, and the failed suspension rods are dangling in the air. The third floor walkway remains unaffected because it was set off to the side. Here is the third floor walkway still in place. So what went wrong? The cause of the failure was a change made by the steel detailer, WRW, a subcontractor to Havens, and at Havens' behest. And Havens, of course, was in turn a subcontractor to Eldridge. And the change was to the suspension rod design shown on the structural engineer Gillum's drawings. Why did WRW at Havens' instigation make this change? It was because of two constructability issues. First, the Gillum design required continuous suspension rods approximately 40 feet long. Havens determined these would be unacceptably expensive to procure and install. Second, the suspension rods would have to be threaded for approximately 30 feet of their length in order to install the critical nut on the rod that would support the fourth floor walkway deck. This was determined by Havens to be unacceptably expensive to fabricate and install. This is the change that WRW Havens made to Gillum's design. This is Gillum's design for connection of the second and fourth floor walkway decks to their suspension rods. This is the change that Havens WRW made to Gillum's design. Rather than the single continuous 40-foot long suspension rod, Havens changed the design to provide for two separate shorter rods. In Gillum's design, the load on the nut at the fourth floor walkway was P, whatever it is. In Havens WRW's design, the load on that same nut is 2P, twice as much. There was an additional consideration. Gillum's original design sized the suspension rods such that they were strong enough to support only 60% of the imposed load based on, and this is important, code allowed stresses. But given the difference between code allowed stresses and actual yield stresses of materials, this was not a fatal error. It was an error, but it was not a fatal error, and it did not cause the incident. More about this later. Here is what the incident looked like. And now the finger pointing begins, the post-mortem. Havens said that they notified Gillum of the change by telephone. Gillum denies having received any such telephone call. Does any of this sound familiar to any of you? Havens submitted over 40 steel fabrication drawings to Gillum for review. Included on one of these drawings was the fatal change. As is conventional practice with engineers, Gillum reviewed and returned the drawings stamped, quote, reviewed only for conformance with the design concept and for compliance with the information given in the contract documents. Havens proceeded to fabricate and erect the structural steel for the project in accordance with the fabrication drawings. Several participants in the design and construction process purported to have told Gillum of concerns that they had about the safety of the proposed change. Included were the construction detailer, WRW, the steel fabricator, Havens, the architect, the master designer, PBN DML, and a technician somewhere along the line. Now, is there anything interesting about these allegations? Particularly, is it interesting that Havens, who made the change, purports to have called Gillum to tell him that the change he, Havens, made was unsafe? This was an incident that attracted national concern, and the National Bureau of Standards, today known as the National Institute of Standards and Technology, which is a very highly technically competent government agency, was selected to undertake a technical investigation following this collapse. NBS, the National Bureau of Standards, determined that the failure was due to, these are words directly from the NBS report, the design change which led to the failure at the box nut suspension rod connection, and it was contributed to by failure to design the suspension rods to code-approved stresses and failure to provide redundant suspension rods. The National Bureau of Standards report specifically said, and I quote, under the original hanger rod arrangement, Gillum's design, the continuous rod, the box beam hanger rod connections as shown on the contract drawings would have had the capacity to resist the loads estimated to have been acting at the time of collapse, end quote. And this is the executive summary. It is taken from the executive summary of the actual NBS report. Under the original hanger rod arrangement, a continuous rod, the box beam hanger rod connections as shown on the contract drawings would have had the capacity to resist the loads estimated to have been acting at the time of collapse, period. The Missouri Board of Registration undertook an investigation. Some might call it a witch hunt. That's a judgment call. The Missouri Board of Registration hired lawyers, not engineers, to undertake a technical investigation, such as that undertaken by the National Bureau of Standards, but lawyers. And the lawyers prepared a 457-page report that found Gillum and another professional engineer in his office guilty of gross negligence, misconduct, and unprofessional conduct. Their licenses were canceled and their careers were effectively ruined. The Missouri Board of Registration's report contained no technical analysis. It ignored the findings of the highly technical, highly competent National Bureau of Standards report, and it essentially consisted of 457 pages of testimony by the many parties involved in the project, denying responsibility for the incident in any way. Now, was the disaster preventable? Clearly, it would have been prevented if Havens WRW had properly designed the changed detail or not changed Gillum's detail at all. Other actions that could have been taken that would have probably prevented the incident would have been if Gillum had provided redundant suspension rods, and if Gillum had sized the suspension rods in accordance with code-approved stresses. That being said, again referring to the National Bureau of Standards report, the cause of the collapse was the change to Gillum's design that Havens WRW made to the connection detail at the second and fourth floor walkway decks. The postmortem effectively placed all of the blame on the structural engineer nominally of record, Gillum. But this raises questions. What is the responsibility of Havens, which held itself out to its customers as providing engineering services in addition to fabrication and erection services? And it instigated the change for economic reasons. What's the responsibility of WRW, which designed the change under the direction of its registered professional engineer? What's the responsibility of the master designer, the architect, PBNDML, which held itself out to its customers as being responsible for all aspects of design of buildings? What's the responsibility of Eldridge, the general contractor, which was responsible, held itself out to the public as being responsible for all of the construction on the project, including the work of its subcontractors, Havens and WRW? What's the responsibility of the owner, Crown, which did not fund additional structural engineering review by Seiden Page after the earlier atrium roof collapse, and after Gillum recommended and requested funding for a full-time inspector at the job site? Here, I believe, are some realities that we need to recognize. The building design and construction process is highly complex. It is not only technically complex, it is organizationally complex. It involves many people with different capabilities, motivation levels, and economic objectives. A second reality that I believe we have to accept is that people always make mistakes. It's human nature to make mistakes. Even structural engineers make mistakes. Any process where people are involved needs to recognize this. A third reality that I believe we need to recognize is that economic pressures are very powerful forces in the building design and construction industry. All of the members of the building design and construction team are under enormous economic pressures. Most, if not all, obtain their work through price competition, competitive bidding. Another point that I believe we have to recognize is it is axiomatic that someone cannot be held responsible for achieving an objective without commensurate authority. And in building design and construction, an essential part of that authority is budget authority. It is also axiomatic, however, that owners will never give up budget authority to anyone. And finally, although all members of the design and construction team do not have the same level of expertise, all do have some level of expertise. Therefore, to prevent events like this happening in the future, take advantage of this. Force as many sets of eyes as possible to look at the drawings, specifications, and other documentation associated with the project, such as change orders, requests for information, test results, and so on and so forth, because someone may catch these mistakes. The cause of this tragedy was an ineffective change management system. To prevent this type of incident from occurring in the future, three things are important, I believe. A clearly defined organizational structure for the design and construction process. Clearly defined and enforced processes for the process. And a third approach that I believe has a lot of merit is independent constructability reviews on major projects. This is when a completely independent firm with expertise in engineering and construction is brought in to review the relevant documents as the project proceeds. The drawings, specifications, change orders, shop drawings, requests for information, etc., etc., etc. In the case of this project, many entities, persons and companies that might have caught this mistake by Gillum did not have an opportunity to review the documents where the change was made, the shop drawings. They probably also had a very low motivation level to take their time to look at the shop drawings for the steel erection. But someone along that more circuitous but essential path, from the detailer to the fabricator Havens to the general contractor Eldridge to the construction management firm Concordia to the master designer architect, someone might have spotted an error like this. But when that rather circuitous but essential process is short-circuited, these potentially useful sets of eyes do not have an opportunity to contribute to the review. So the constructability review, I will reiterate, is an approach that I think is very helpful with complex projects. So to summarize how I see this project, this incident, that what needs to be done is to force as many sets of eyes as possible to look at the drawings, specifications, and other documents associated with the process. Force the team members to take things seriously by requiring sign-off on every substantive decision and action. Not approval. Certainly isn't appropriate to have a mechanical engineer on a project approve a structural change, but I believe the mechanical engineer or even an electrical engineer should be charged with at least looking at shop drawings and change orders and requests for information and this sort of thing, simply because he or someone in he or her office might spot a potential error. And then finally, the third step that I think is very important is to convince owners to fund on complex projects, relatively complex projects, to fund an independent constructability review. And they will save more as a result of a constructability review than the constructability review will cost. With that, let me thank you very much for being able to chat with you today, and I hope you found this sort of interesting, and look forward to chatting with you perhaps again somewhere down the line. Thanks a lot. Bye.